What are some of these standards? ISO, we've used them before, the international standards. 27001 and 002, talking about the information security management system, your overall program. And then in concert with that, 002 gives a code of practice for how you manage that program. If you're collecting this information from stakeholders, how do you go about collecting that information? Literally, what is it that you do to get that information from them?
Interview them.
Interviews are very helpful. They're a great tool. It's kind of difficult sometimes. It can be maddening listening to non-geeks try to explain what they want from their IT systems because they treat all of it like magic. They'd like it to also warm up their coffee and wash their car. Interviews are good. The risk of interviews is what? To a business owner, what is the absolute most important function in the organization?
People's effort.
What's that?
People's effort. The amount, like using up their
people?
time.
Which effort? Which operation?
His people's.
Theirs.
Yeah.
Right.
Theirs. Yeah,
Right.
That business owner thinks that they are the most important thing. That if they didn't exist, the organization wouldn't exist anymore. And that even goes to the landscaping team. If you ask them, without the grass cut properly, the organization would not exist anymore. What are other ways of collecting this information? Interviews are time-consuming. They're difficult. You need often an experienced interviewer. Survey is great. Survey is awesome. You can do it. People can do it on their own time. You can automate it. You can distribute it. There are great online tools right now that may be very cheap or even free, right? Good. What else? Metrics of previous audits, perhaps. Maybe you have historical data. Maybe you have sales data that show the operations that are the most vital. Those are all good ways of collecting the information to drive your requirements. Senior management should also have some input. Let them. Okay. We talked about COBIT before. It's also a good way of organizing information to build your framework, to build your architecture. Comes out of ISACA, an audit organization, which COBIT is often used for. It's a process-driven implementation where it looks at how things occur. Operations not in terms of set points, but as things progress, as transactions take place. It's got 4 main domains. COBIT 5 might have some more of these, actually, now that I think about it. COBIT 5 just came out. Types of security models that you might use in your security architecture. State machine model. What's the state mean when we talk about the state? There's my train. State going from one point to another. What do we mean from one point to another? We're picking up the PC and moving it across the room?
It goes from being turned off to turn on versus logged in, logged off.
Good. Excellent. Excellent. And time is crucial when we're changing states. We only want people to log in at certain times. If it's outside those time boundaries, we know that something untoward has taken place. It can only be administered at certain times. You can only change permissions during certain times because administrators can only log in during certain times. Multi-level lattice models. Anyone familiar with these? Subjects and objects, active and passive. What are we usually talking about? What are subjects and what are objects? Users and
Computers.
systems. Yeah, good. Often it can be programs and files. The data itself can be seen as an object. And talks about how they're going to interact with each other. What are users allowed to do? What are programs, what are applications allowed to do? Matrix-based model. We like matrices because we get to do this. Access control is a very common matrix. We have a list of users, and for each user, we have all the permissions that they're assigned to them. Non-interference models. We don't want to allow higher level actions, high classifications, to affect what the low-level users can see because they're operating at different security levels. The admin is up here and the user is down here. Users don't have to know what other permissions other users have, for instance. Information flow. How is information going from object to object? How is it being processed? How is it being manipulated? Models can look at that from that perspective. There are also confidentiality models. In addition to all these other security models, we have confidentiality models such as Bell LaPadula. It's got 4 basic components. We've talked about many of these already. You're going to classify your information and label your information. But now we're talking about clearances and modes of access. Again, your permissions. Your users, based on what authorized sensitivity level they have access to, will have different sets of permissions. Who's going to determine what a user has access to? You can use many different things.
The data owner.
The data owners are definitely going to decide who gets access to their data. What else?
The job description.
Their job, their role might decide what they have access to. Your environment might decide what they have access to. Their employment level might decide what they have access to. Good. And the subjects and objects themselves. In Bell LaPadula, there are different properties. Simple star and strong star. In simple, a user, most likely, as the subject, can read but not write, and can read down but not up. Meaning, they can read information at a lower classification level than they, but they can't read higher classified information. Why do we want that? Why do we want that? What security aspect is that addressing?
Need to know. Need to know.
Yes, sir. That's need to know. Literally, that's the definition, right? They don't have need for that higher, otherwise they'd be cleared for that higher. Excellent. Star property. They can write it, but not read it. They can write up, but not down. What possible use is that to anybody if they can't see it? Why are they writing up? Doesn't that violate need to know? Doesn't that violate confidentiality? Why are they writing up if it's a higher state than they are?
Because they write it and then it's just determined to be more important.
So
They originally write it and then it's determined to be more important.
Except that they're granted this permission. They're allowed to do this. There doesn't have to be an inspection of it. That's good. I like that, though.
A survey is a good example of that, where you can write into it, but you can't go back and edit it afterwards.
Or even see the outcome of
Right.
other survey results.
Right.
That's an excellent example. Another thing that was suggested in the book was internal reports. Subordinates can write up so that their superiors can read the reports, but they can't read other reports at that level from their colleagues at the same level. Good. Strong star. Subject can read or write it, but only at their own level, and that makes sense. A little bit of trivia. This may be an apocryphal tale, but does anyone know how they arrived at the star for their model? Why did they decide to name it the star property and strong star property?
Because of the wild card.
Yeah, that's the legend anyway, is that they left the wild card in there and they were going to come up with some cool name for it right before they published, and they shipped it off to the editor before they remembered to put that name in there. I don't know how true that is. That's a neat story anyway. We're only talking about confidentiality. It's got nothing to do with integrity or availability, especially with the star property. If they can write up, there is no integrity there, right? Good. Biba. Similar to Bell LaPadula, it's also latticed. This one's slightly different in that it does offer integrity, but not confidentiality. It's about not corrupting the data. The simple integrity, you can read information at a greater integrity level. Why are we allowing that? Doesn't that violate all the principles? Doesn't that violate need to know?
You're not always in an environment where that's the priority.
Good. It may not be necessary for the job you're doing, but what's the real linchpin here?
It's more about integrity.
Integrity, not confidentiality. So they can read more trusted information. They can have access to more trusted information. They're just not modifying it. Star integrity. They can write to objects at lower integrity levels. Again, this makes some sort of intuitive sense because since you're writing down, if what they have is less trusted than the level they're at, that's okay. That's what the lower levels are for. And the invocation property. Subject can't run a program or an application or can't have access to a system that can use those capabilities of the more trusted subject because they've inherited them. It separates that to make sure that that does not take place. Clark Wilson, 3 integrity goals. You don't want changes by unauthorized users. That makes sense because that would be an attack. That's literally the definition of it, right? But it's also intended to stop authorized users from making undesirable changes. That can be very complex. What do we have to check to make sure that's the case?
Need to know.
Need to know boundaries, input limitations, right? Constant mediation between every subject and every object. What's the problem with that? Really heavily resource intensive, right? It's not a straightforward, easy system, and it's expensive. In this case, we talked about this. Gregory, I think you mentioned this. This is where we put that into place where everything has to be reviewed before it's granted access, before it's actually executed, right? We have transaction steps. There is some internal consistency. Users are not given the ultimate freedom to create, to modify, to delete objects. Each thing has its own chain of authority. And it creates those linkages. The program is supposed to ensure that those linkages are exactly what they were supposed to be, that they are being enforced, that they are enforcing the policy. Lipner complains. Lipner contains elements of Bell, LaPadula, and Biba, but it also adds some concepts of job functions and roles. And we're shooting both for the C and the I here. This is more role-based. Again, each role is restricted to its own domain and can't touch other domains. This was the first model that divided objects into data and programs. In some models, programs are seen as subjects instead of objects. Brewer-Nash, Chinese Wall. Why is it called the Chinese Wall? Great Wall of China. It's designed to prevent conflict of interest. Just because a user can see data from one client doesn't mean they should be allowed to see data from other clients. In fact, they're supposed to be restricted from doing so, so that wall is put into place. It's supposed to separate that based on the need to know for those projects, for those clients. And it's based on what the users do. They're the ones defining where those walls are set into place. When they choose a given client, all the other clients are now restricted from them. The model is designed so that the program's reactive to what the users select. Graham-Denning. It's how subjects and objects are created, assigned rights and privileges, and managed. All of those things are cut into sets, and all these rights are granted to each of them so that each is known and that they're limited to what rights are assigned to them. Is that Russo or Ruzzo? Anybody know? I was unable to find out. I went and looked, but I couldn't find the pronunciation for that. I was impressed that I could find Scitali. That was the one. The Spartan one was a win for me. Harrison Russo Ullman is what we'll go with. Similar to Graham Denning, it is supposed to prevent the subjects from getting access through a permitted subject to those objects. What is this concept that we talked about earlier? We mentioned that. It's invocation. That is the term. You can't use a capability of another subject to get access to an object or rights over an object that you weren't originally granted. Does that make sense? Sorry about that.